So the goal of this next tutorial is to discuss about parametric simulation. The idea behind parametric simulation is that you can simulate a circuit by varying a given parameter. So you run multiple simulations, but instead of doing that by hand, you can instruct the simulators to, for instance, choose a resistor, a capacitor, whatever component you want, and change its value and repeat the simulation multiple times by showing you the results all together in the same plot. For instance, we will make an example of a very simple filter where we will be changing the value of a resistor, and we will see how the both diagrams are modified, and we will see all of them as a multiple result put together in an ensemble. So let's start with this. The idea here is the following. We have an RC filter, and the RC filter is very similar to those that we have already seen in the previous tutorials. So we suppose we have a resistor, and we suppose we have a capacitor like this. Of course, this is a circuit of which we will want to study the frequency response. So we will start putting inside the circuit a voltage source. That, of course, will be an AC source, as we will see in a minute, that we can put right here. Then, if we remember the shortcut, F3, to put down the wires, we can start connecting this terminal of the power supply to the resistor, and then connect the resistor to the capacitor, and then connect the capacitor back to the voltage source. Of course, we know that the circuit is going to work only if it is connected to ground, so if there is a node which is connected to the reference potential. And we will decide to put, which is kind of reasonable, the reference ground potential here connected to the minus terminal of the voltage source, as you can see over here. Now, our idea is the following. We will try to simulate the circuit with a fixed value of this capacitor, which we can, for instance, put at 100 nanofarad, just to give it a value, which is reasonable. And then we will decide that we want to simulate this circuit for a varying value of this resistance. Of course, we already know how to simulate the circuit for a fixed value. So let's see what happens if we want to basically have multiple values of R simulated at the same time. How shall we do this? The first thing we do is to right-click on this resistor value and instruct the simulator that we are not willing to use a fixed value of this resistance, for instance 100 ohm or so, but we want that to be a parameter, which we can write like this. Between curly brackets, we will write a name, for instance R-var, which is a name that we use to indicate that this is a variable resistor. Once we have done it, we push OK, and we see that now we have this R-var between curly brackets as a parameter, as a value for this resistance. That's the first step. The second step is to create a SPICE directive. To create a SPICE directive, we go with the mouse here, and you see this button corresponds to the creation of a SPICE directive. And I click here, and I have the possibility of writing a directive for SPICE straight here. I could also write a comment, by the way, but in my case, I want to write directly as a plain text a SPICE directive. What I plan to do here is to write the directive dot step, which basically is the directive which is telling the simulator that I'm willing to step the value of a parameter, in this case, the parameter R-var. So at this point, I write dot step param, which is exactly used as an instruction for parametric simulation. And then I need to tell the simulator what is the name of the variable I want to step. And in this case, I will choose R-var. Now, of course, this set of instructions is not sufficient, because I am just telling the simulator that I want to make a step on a parameter which is called R-var. But I need to tell the simulator what are the values that I want to use in this simulation, where I'm varying parametrically the value of a given parameter to get an output. I have two possibilities. The first one is to write list. So to tell the simulator that I'm going to use a list of values for the simulation. A possibility, for instance, would be to use a list of values, let's say 100, 1,000, 10,000, and then the simulation will be repeated 3 times, one for each of these 3 values, and that's a possibility. The second possibility that we will see later on would be, instead of using a list of values, to tell the simulator what is going to be the first and the last value, and then what's going to be the step between these values, in order to have the simulator create autonomously the list of values to be used. And that can be handy in case the values to be used are more than 3 or 4, so you don't want to either calculate manually them or to just write them down. But in this case, we're going to use the directive. Let's see the directive once more. We use .step param, so we're going to step a parameter. The parameter is called rvar without the curly brackets, and we're going to use the list option and to list 3 values, 100, 1,000, 10,000. Now, this is a SPICE directive. If you have never used it, the idea here is the following. After you press OK, you will find the text of that directive copied, and you can basically put it down on your schematic wherever you want. I will put it down right here. You remember that the simulation starts with instructions like this, but obviously this is not enough, because we still have to tell the simulator which kind of simulation we want to carry out. If we want to carry out a DC simulation, a transient simulation, and so on and so forth. Since we're dealing with a filter, we might be interested in looking at what is the frequency response of our filter, so as a function of the rvar parameter. So what we will be doing will be to define this voltage source as an AC source. So if I right-click over here and I press on Advanced, I have a chance to set what the small signal AC parameters of that voltage source shall be. And as we have done previously, what I will be doing will be to put an AC amplitude of 1, so it's easier for me to calculate the gain, and no AC phase specified. In this way, I am all set, in the sense that the voltage source is set as an AC source of amplitude 1. The last thing I need to do before starting running my simulation is to basically instruct the simulator that I want to do an AC simulation. To do this, I go to Simulate, Edit Simulation Command, and here, you remember, I can set up the parameters for AC analysis, DC sweep, and blah, blah, blah. What I will be choosing is AC analysis. And I want here to carry out a sweep. Of course, I'm going to plot both diagrams, so I prefer to sweep the frequency in decades and to use at least 10, let's say 20 points per decade. I will use a very broad frequency range so we can see what the circuit is doing. We will be starting from 1 Hz and a stop frequency of 1 MHz. Please remember that it's not enough to write 1 M, you need to write 1 meg if you want that to be 1 MHz and not 1 millihertz. Now I will press OK and my directive will appear. And now I am ready to launch my simulation. In order to launch my simulation, I will press Run. And, as usual, what will happen is that my panels will split. On the bottom I will still have my circuit, and on the top I will have a frequency plot, in this case, from 1 Hz to 1 MHz. Let me first press here. If I press here, I put down a probe on the voltage source, and I see I have a voltage source, which is ideal, of course, with the same amplitude of 0 dB, which is exactly 1 in volt, in the full range. Of course, I'm not interested in knowing what signal I have put as an input. I am more interested in looking at the output signal, so what the voltage is going to be on across this capacitor. So I will press here. And once I press there, you see I don't see a single baud diagram, but I see many of them. In this case 3, because I have set up a list of parameters. I also see the magnitude, but also the phase. Let me first click here on the right and press Don't Plot Phase. Now we can clearly see that we have three different baud diagrams, and we also can see that the cutoff frequency of the filter is changing significantly with the value of this R var. If I right-click here, I can choose to change the range, and for instance, I can choose the range from between 0 dB on the top and a minus 3 dB on the bottom. And if I do this, basically I can clearly identify what's the cutoff frequency of the 3 dB frequency, basically, of this three baud diagram. In this case, the first case on the left is 158 Hertz. In the second case is almost 6 kilohertz, and in the next case is going to be 10 times higher, so approximately 16 kilohertz, more or less. And this is perfectly reasonable because the RC time constant of this circuit and correspondingly the cutoff frequency is changing by a decade once the resistance is changing by a decade. So that's perfectly reasonable. If I want, I can remember plot phase once again, and I can also decide to rechange the amplitude here, for instance, to minus 20 dB or so that I can clearly see that prior to the cutoff frequency I don't have any variation in the magnitude, and above the cutoff frequency I have a 20 dB per decade decrease. If you remember, I was telling you earlier that the possibility of using a list of values, as we have done here, is just one of the possibilities. The other would be to give it a range and to ask the simulator to calculate the values to be used for a subsequent simulation. If I want to do so, I can right-click here, and you see I have this menu here, which allows me to basically choose between two options. The first one is list. The second could be, for instance, linear. If I choose linear, I can then tell it, the simulator, what's going to be the first value, the stop value, and the increment. Of course, these are still the values that I have put in earlier. They don't make any sense. But I could decide, for instance, to go from, let's say, 500 ohm all the way to 10 kilo ohm with steps of 500 ohm. In this way, I can have a much larger number of simulations done and a much larger values of R var considered, calculated automatically by the simulator. Of course, I could also change the parameter in octaves or in decades or in list as we've done earlier. But let's do that linearly. So I press OK. I see that now the directive changes a bit. Instead of having the dot step, param, R var, list, the keyword list has disappeared, and I just have the starting, final point, and the step. Ready to launch the simulation again, I will launch it. And what will come out is at this point a big number of curves, that you can have. And each of them is corresponding to a specific value of the resistance that we have calculated. This is a very powerful tool that you can use whenever you need to understand what's going to be the behavior of your circuit under different values of a given parameter. My strong recommendation is to use this in order to verify some hypotheses and not to design a circuit. Don't be the kind of student who just tries random number in order to set up a cutoff frequency instead of calculating that. Start always from a manual calculation and then find your way to verify your hypothesis by means of, for instance, parametric simulation, as we have seen in this tutorial.